Hello ladies and gentlemen, and thank you for listening to Mr. Laxton's video on these Algebra 2 7.3 notes. Alright, so my essential question is today is how do I compute function operations such as adding and compositions? Okay, so how do I compute function operations such as adding, subtracting, multiplying, all those guys, we're going to do that today. And the new really thing today is compositions. All right, so operations and functions really are just this. It's these four basic operations. We're going to take some polynomials today and these functions, and we're going to add them together, we're going to multiply them together, we're going to subtract them together, divide them together. So it's nothing terribly new. We've done those, the polynomial adding, subtracting, dividing, multiplying, but it's kind of just the notation that's a little bit different. Okay, so here for number one, it says the notation find h of x if h of x is f of x plus g of x. And it's really not that hard here for the adding because I just take my f of x, so h of x is just equal to my f of x, which is x minus 2, plus my g of x, which is x squared plus 1. All right, so now I just add these guys together. I notice here that I can combine some like terms, this negative 2 and this positive 1. So I have equals, I'm going to put the x squared first, plus x, and then minus 1. Is that what those guys combine to? All right, so nothing really terribly new there, just plugging in my f of x when I see f of x and my g of x when I see g of x. All right, so now this one is subtracting, which is a little bit tougher. So I have h of x is equal to my f of x, which is x minus 2, minus, and don't forget you do need the parentheses here because I'm subtracting this whole polynomial. And don't forget here is that instead of subtracting, we like to add the, where did it go there? There it is. We like to add the opposite of both these guys. So if you want to write a little note there for yourself, add, if my word would load here and it is not loading, add the opposite there. So we're going to go through, add the opposite, and then we're just going to combine like terms and add these guys just like we have done before. So I'm going to add the opposite. Come on, word, let's work. Oh, there we go, there we go. All right, so now I got a bunch of things that I got to erase because that didn't work out very well. All right, perfect. So we have to add the opposite. Perfect. So now I just go and combine my like terms again. Again, I have negative 2, and now it's a negative 1, though, that combine. Be careful here as I put my first term first. It's going to be negative x squared plus x minus 3 now, because negative 2 and negative 1 make negative 3. All right. The next one, it says find f of x times g of x. So I'm going to plug these guys in and multiply them. So now here I have h of x is equal to x minus 2. Put that in parentheses, and x squared plus 1. All right, so now I just go through and FOIL these guys together. I bring my x onto the x squared, my negative 2 onto the x squared, all those FOIL guys. All right, so now I have x cubed. X times 1 is going to be 1x. Negative 2 times x squared is negative 2x squared. And negative 2 times 1 is negative 2. All right, that's good. That's final. You could put the negative 2x before the 1x, but you don't have to. Doesn't have to write it in standard form here. All right, the easiest one most of the time is the dividing. So h of x is equal to f of x, which is x minus 2, divided by that x squared plus 1. And for right now, don't have to do anything more with those. That is just simplified there. You just toss them in and you're done. All right, so number 5 here, it asks us to take, it's got some different, let's talk about these power functions here. It's really just functions of ax to the b power. Nothing really crazy there. Those are just the different things that we plug in for h of x and my f of x and my g of x. All right, so this one says h of x equals f of x plus g of x. So my f of x is 3x to the 1/3 plus 2x to the 1/3. All right, so now I know here I can use these guys. If I have 3x to the 1/3 and I have 2x to the 1/3, then I have 5x to the 1/3. All right, add those guys together and we're done. Now subtracting them is really the same thing, but we're just subtracting them. I have h of x is equal to 3x to the 1/3 minus 2x to the 1/3. So then 3x to the 1/3 minus 2x to the 1/3. I can combine some like terms there, so 3 minus 2 is just going to be 1x to the 1/3 power. All right, done. Adding and subtracting them. Gets a little bit tougher down here with the 7 and 8 with dividing them and multiplying them here. My h of x is going to be equal to what? The 4x to the 1/3 times my x to the 1/2 here. All right, so if I multiply these guys together, I'm going to have 4, and then I have x to the 1/3 times x to the 1/2. I add those exponents together because we're multiplying the bases. So now I can make these guys into sixths for my least common denominator. So here I'm going to have 2/6 plus 3/6, so that's just getting a least common denominator there. We've done that a bunch of times with these fractions. So now I have 4x to the 5/6 power. To probably make this into my most simplified answer, you would go 4, then the radical, that's 6x to the 5th power there. All right, so moving in from that exponent form to the radical form like we've been doing in class. All right, so there, multiplying those, you have to add those exponents there. That's the main thing. All right, so for number 8, you have to divide these guys. So I have h of x is equal to 4x to the 1/3 divided by x to the 1/2. All right, we talked about this in the last section, that if we divide these these bases with different exponents, we can take them and we can subtract them. So I have 1/3 minus 1/2. All right, and got to get a common denominator here. So I have 4x to the 2/6 minus 3/6. And 2 minus 3 is going to be negative 1/6. So I have 2x to the negative 1/6. Bring that guy into the basement to make him happy, right? So I have 4 on the top, and then the 6th root of x on the bottom, all right? Because x to the 1/6 just becomes the 6th root of x there. All right, perfect. So that one's kind of using some of those properties of exponents there in 7.3. All right, so as I scroll down here to the last page of notes, it has this big new vocabulary word, compositions. All right, and compositions are like this: h of x equals f of x, f of g of x. So notice it's not f of x, it's taking f of g of x. And really what this means is that f of g of x means this. You're going to plug in g of x to every x in f of x. All right, so here it talks about these guys, f of g of x and g of f of x are not the same. We're going to find that out here in number 9. So if I look at this, f of g of x, that means I'm going to take my g of x, which is x squared minus 1, and I'm going to plug that into every x in f of x. So my guy here is going to be 2, and I'm not going to write x, I'm going to write my g of x, which is x squared minus 1. All right, so I'm plugging in my g of x for every x that I see in f of x. So now just the last little thing here, 2, you can distribute this guy in here. So what I'm going to have, 2x squareds minus 2. There. All right, so now number 10 is backwards the other way. It's g of f of x. So I'm going to take my f of x and plug it in for every x that I see in g of x. So I'm going to write my g of x, but I'm not going to write my just x. I'm going to write 2x, and then that guy is being squared minus 1. All right, so 2x squared is just going to be 4x squared minus 1. All right, that's it there. All right, the last one is f of x. So I am going to plug in f of x. So f of x, which is 2x. I'm going to plug that in to everywhere where I see x and f of x. So I'm going to plug in 2x into my x here. So that's going to be 2 times 2x, which is just going to be 4x. All right, so compositions are new. You guys haven't seen something like that before, but you're taking whatever's the innermost one and plugging that in for all of your x's in the outermost one. All right, so compositions, we'll do a lot of examples like those in class. Please come find me if you have any questions. Thank you.